This might work.
Yeah, that's what's
Come on.
So I guess you bring trash can over here.
Some idea of what was going on.
Everyone's like holding their trash.
I want to make this.
I hope it is. I really do hope it is.
Yeah. I don't think so. Or it's fucking freezing. It's hard to say. I mean, do you see it moving when I move it?
Yeah.
Okay. So. No, there's a little like four-way. There's a little motor on here. It's going the wrong way. No, I'm trying to hit the. Yeah, where's my VR glove? Okay. Well, it'll have to do. So, and it looks like, are we getting on? So we're getting audio, we got video. All right. I'm going to mute this for now. Okay, yo, check 1, 2. Whoa, yo, holla. Okay, good.
Yeah, it's like a triple meetup. My group clinics LA, UUASC-LA.
Yeah, well.
You can turn it on. Yeah.
No.
I grabbed some of those.
Yeah, there's a lot of
Filled out all the forms. Name, address, telephone, social security. Keep on this. You had to tell them about all your jobs. You had to tell them about your neighbors. My neighbors,
Yeah, but it would be traffic.
It's like,
So since the last year, it seemed like there's activity from
This is the DSP program.
I'm sorry, I don't recognize it.
Sit here.
Because they have a home.
It's just that I was gonna take care of my.
Yeah, well, you know what? I was too.
Yeah, that's how it's supposed to. Yeah.
I already got you. We got all the plans. So that was. But yeah, for this.
No, they're not there. No, I don't buy
Things like salaries. Take a look and see. You've got valuable data. You've got valuable data. What do you do to preserve your data?
Yeah.
Carolyn's just 7:20.
Okay, good, good. I'm not in a rush. You know me, I'm not in a rush. Okay, cool.
Hi, John.
Hey, how are you? Glad I got here. You doing okay? Cool. Glad to hear it. Glad I got here.
Cool.
I don't think I've been on this meeting.
That's nice.
We've had a few meetups here.
I haven't been getting to worry about it.
No, he was alive. I was as well.
Oh, yeah. You're supposed to be controlling.
I had an old dog.
It's heavy on the line.
Yeah, I know. Yeah, so SEC rules.
We're gonna start at 7.
Might as well. Wow. Well, my son, I'm worrying about my son because my ex died within the last couple of months. And so, it doesn't mean anything to me, but I'm worried about, concerned about them. So, yeah.
Well, it's been a while ago, right? On the Thomas
Yeah, I don't know. Because there's all kinds of stuff going on there, but physical.
I'm so sorry to hear that. That is a weird thing.
Yeah.
Somebody did. Oh, really? Sometimes has to be all fine.
I figure everything is so interesting when I have no idea what they're all in bag, but it sure would be a lot.
Yeah. Well, that can be.
I'm not afraid of that, boy, I'm not. I just don't want to get myself.
He was fun. He lost a lot. We had come in yesterday. He had some he said they put that in, that's like.
Well, that doesn't all that kind of thing compared to getting there.
Right, no, that's the thing. You've been doing okay. Tight, you know. But you could see not there a lot. But now so now I'm free up.
Well, it's nice to see you. I haven't seen you in a while.
Yeah, no, this should be.
Everything is going perfectly for me, which is very, very different from the last 20, 30 years.
Yeah, really? What's happening? You working or just making ends meet? So,
I'm working for the city of LA,
cool. Wow.
and I've got parking in the building. I'm right across the street from Union Station.
Wow. You know, we have a data center over there. You know, there's a big data center. I work at Verizon Digital Media, but it's, there's some other, I mean, we just have space. You know, it's 100 different people in space. And, yeah, you in the back of Union Station around the corner is a big data center. You wouldn't know unless you knew where to look.
I'm over on the other side where that Denny's is. I'm right across the street from the Denny's too.
So what are you doing over there?
It's so weird.
But it's a gig.
It changes weekly. I think of this department I'm working in as the hardware department or the IT department of the city of LA.
Huh.
But they formally are the communications department. And so they're responsible, the biggest thing that they do is maintain all of the radios that 12,000 police officers use and 5,000 fire department and then all the other departments of the city, whenever, you know, maintenance people or anything that has a radio, these guys are responsible for it.
That's pretty cool. Nice gig, man. Hey, congratulations. Good right for you or you. You can live efficiently, so you just get a nice steady gig. Boom.
Yep, that's it.
Kind of. It just doesn't happen so that this that much doesn't result in it is useful, except that it sets the camping service to a hash, not a status symbol. So it's called, is it failed? Nope, it's a hash. And so it's always okay. Or as long as the features. And then also goes, oh, it's more. All right. Hello. Hello.
Hello.
All right.
Hey.
So who is here for the container talk?
Oh, we're here for the
Okay,
beach.
excellent. You've come to the right round. Welcome. So very exciting night. Tonight we have, okay. Am I in?
Yes,
All right, thank you.
yes.
Thank you, Patrick. All right, so we're doing a joint meetup tonight. We've got LABSA, all right, the League of
Yay.
Professional System Administrators. Thank you, Jordan.
And you're,
And I'm a professional system administrator. I'm the meetup organizer. And UUASC-LA started out as a special interest group of UUASC, all right, the Unix Users Association of Southern California.
one of the oldest technical meetups in town.
That's right. That's right. So I found out about UUASC-LA in a computer magazine in the mid-90s. I wish I could remember which one, but it was an ad. Herschel ran an ad.
Microtimes.
Microtimes, that's it. All right, and Linux LA. All right. So
How old are you?
me?
No, come on.
Linux LA is a relatively recent meetup that you kicked off, right? Yeah, so that's very good. All right, so we have some exciting more meetups coming up. We're going to have Gary Demos in September. He is a Oscar winner. He is a computer graphics pioneer. He's got credit in Tron, The Lost Starfighter, and he gave a presentation to UUASC in 2011, showcasing his work on real-time encoding on Linux and the challenges he was having at the time. He got some help from the audience, and so he's coming back. He's doing a lot of 4K stuff, and he's running into some new challenges.
Cool.
Yeah. And also,
And the last time he brought like a big 4K monitor, right?
he did a live demo. He basically did a live demo of the real-time encoding. And not only encoding, but also the special effects that he was introducing into the stream. So it was very cutting-edge stuff, and he publishes papers in this, and he's a consultant in the industry and so on. And we're planning to do, it's still putting the finishing touches on the organization. It hasn't been posted yet, but we're planning to do a Build Your Own Cloud workshop with Brian Bennett. Yeah, come in with your gear, and we'll install the cloud software on it, and in the end, we'll network it all together into one big cloud. So that should be really fun. And it's going to be like not an evening meetup. That's going to be like a whole day thing.
Cool.
So save the date, October 2nd.
Is that a weekday or a Saturday?
It's a Saturday.
Okay, good.
Saturday. Yeah. All right. So Jordan, would you please tell us about the UUASC?
I'm Jordan Schwartz, and welcome to, among other things, the Unix User Association of Southern California, August 2016 meetup. Just want to cover a little bit of UAC business, and then we'll move on with other meetups business. And then actually the presentation. About UAC, we're one of the oldest tech meetups in town, and we like to host talks on anything, any kind of talk with a Unix or Linux type tangent. And we're always looking for potential presenters. We try to meet once a month, usually on the west side here, usually the first Thursday of the month. And then I also try to live stream the events via Google Hangout on Air for the people that can't get across town or across the state or across the country, but still want to see what's happening here. So in order to be a member of UUAC, we ask that you join our mailing list. Is there anybody who's not a member of the UUAC mailing list? If you want to join, just go to uuasc.org, and there's some info about joining the mailing list. Also, these days we pick up most of our new members from meetup.com, so staying in touch there helps as well. I think that's, since we got a lot of other stuff to deal with, I think that's all. You can reach me from the meetup site or on the mailing list if you're interested in presenting at UAC. Just shoot me some email. Oh, I guess one other thing that we're all interested in is SCALE, the Southern California Linux Expo. It's happening, I think, in March this year back in Pasadena, which is freaking awesome. SCALE, if you don't know, is a grassroots Linux open source event that covers a lot of interesting topics to these meetups specifically. And they did announce a call for papers already. So if you're thinking about presenting, now's a good time to get something together. And then if you want to flesh it out, you could do it at you could first present at UUAC or Linux-LA or LAPSA or a combination thereof, and then make it to the big stage this March at the Pasadena Convention Center. So keep an eye out for SCALE call for papers out there as well. Anyway, so next up, we always have to thank our host, Carolyn Oswald from Q. And here's Carolyn. And oh, by the way, she happens to host Linux-LA as well. So take it away, Carolyn.
I'm Carolyn. For anyone that doesn't know me, I work here at Q. A couple of you were asking, what does Q do? We are an IT staffing firm. So if anybody needs help, if you're looking for a job, you have a friend that's looking for a job, if you're looking to hire, or even if you just want help with your resume, advice on the market, whatever, we're always happy to help. We do specialize just in technology and mostly just here in LA. We do a little bit of Orange County and San Diego as well. So if anybody wants me, I'll be at my desk in the back afterwards, and you can come and hit me up, help you however you want. And we do have a referral program, so if you know anyone that's looking, send them my way, $3 gift card. I do run Linux-LA. I think you've heard enough about all the rest of the meetups, but if anyone's interested in Docker, which I think some of you might be, our next meetup is actually also going to be on Docker again. Docker and stateful applications made easy, demonstrated using Minecraft. So a little bit of on that. So it'll be in about a month on September 7th, Wednesday, September 7th. So that'll be a really good one. So hopefully I'll see you all here. And I think that's it. We'll give it to Brian. Thanks, Brian, for driving all the way from San Diego to be here.
So let me get my laptop unlocked here. There we go. Okay, all right. All right. Who's heard of Joyent? Yeah, good. Who's run stuff on Joyent? Yes? All right, not nobody. That's good. I'm going to talk about actually running containers in production, like for real, not just how we talk about it and then wish we actually were. But before I do that, who likes demos? Demos, right? Okay, right. Let me pop this down. And so here is, all right, VMware. Let's start this baby up. Now this is a blank VM. I'm actually going to go to do this one first, so I can show you that it's actually empty. No tricks up my sleeves, right? Let me get my, where's my cursor? Oh, let go. There we go. Okay. Let's bring this over right there. Oops. I want you down. There. Okay. All right. So I'm going to log into this as root because I went into the rescue system, and this is the default root password down here at the bottom. And there we go. All right. So here I am. Disk info. So I've got two disks here. This one is ATA drives virtual USB. It's 3.73 gigs, and I have a 60 gig disk. If I do DF, you've got RAM disk here. Here's the USB that's mounted, but that's it. There's nothing else, right? Do zpool list, no zpools, zpool import, nothing available to import, okay? ZFS list, no ZFS data sets, right? All right, let's reboot this thing. And what I'm gonna do is, as a teaser to the build your own cloud day, I'm actually going to build a cloud on this virtual machine while I'm giving my presentation. So I have a config file on the USB that's going to preload all of the answers. Okay, so I'm just going to have a couple of prompts here, and then once I do the last prompt, it will install by itself automatically. Do we want to have a pool for, like, guesses on how long it'll take this thing to install? Root password.
5 minutes.
How long?
3 to 5 minutes.
Depending on network speed. So here's all of my options: admin NIC, external NIC. Those are my IP addresses, DNS servers, NTP server. So I'm going to say yes, and it's going to ask me if I want to edit the final config. No, let's just go on. Okay, all right, this is going to run in the background, and we're going to go back to this. All right, so as is often the case with joint presentations, oh, I forgot I gotta.
You have to log in.
No, this is get privileged mode to access promiscuous mode for the NIC because it's doing DHCP. All right, so containers have exploded over the past couple of years, about the past 3 years in particular. But containers actually are not a new idea. They had their original genesis way back in the early 80s with Shroot. Shroot was the first container type system. It was written, as best we know, by Bill Joy, and as best we know, it was done to have a build environment for the next version of BSD while running the current version of BSD. And we actually don't know more than that. I've been told don't bother asking Bill Joy because he won't be able to answer. But later on, Paul Henningkamp for FreeBSD, somebody asked him to build what eventually became Jails. He had a contract where that code was embargoed for 1 year. After the year passed, where the client had exclusive access to it, it was merged into the FreeBSD main trunk. Now at Sun, the engineers there saw the potential that was in Jails. Has anybody used FreeBSD Jails? Yeah, good. But a FreeBSD jail isn't like a full system. There's significant limitations to it. So at Sun, they wanted to take the idea that was part of Jails and bring it to its fullest logical conclusion. So what they did was create a complete virtual operating system, not a virtual machine, but a virtual operating system. So there would be like what eventually became called zones, a zone of the operating system, a full instance of the entire operating system, all running on a shared kernel. Jails and zones were actually not ever intended to be an application deployment mechanism. They were designed primarily with security in mind. And at Sun, they did it because they had, larger and larger boxes, and applications were staying the same size. They wanted to be able to pack more applications into one gigantic box. So their motivation was to sell you bigger hardware that more and more people were not buying in the early 2000s.
And at that time, they were doing hardware virtualization as well.
They did, yes.
You could split systems into hardware isolated 4-socket systems.
Yeah, on Spark they have LDOMs, logical domains, and then on the x86 side they had integrated Zen.
And additionally, with that UltraSpark T1 chip, they had 8-core, so they were doing multi-core before the Intels and AMDs got in the game as well, so they could see where virtualization was going to blow up. And by the way, at UUASC in 2009, we had a Unix virtualization roundtable. We actually had somebody from Sun spin up on his laptop running Solaris 10, spun up hundreds of zones just on his laptop. So it was very efficient at the time.
Yeah. So Joyent was a very early adopter of containers. The origins, like the first maybe year or so, Joyent was running FreeBSD. Once Solaris 10 was out and more so was open source as Open Solaris, they basically pivoted everything going on to zones. So we've been running zones containers in production for 10 years now. But not everybody wanted to run Solaris derivative. So we added support for hardware virtualization, which was a port of the Linux KVM. So anybody that says CDDL and GPL can't coexist together, we've been doing it for 5 years now. Nobody seems to have a problem with it.
What's CDDL, right?
CDDL is the Common Distribution Development License. That's the license that Sun chose for Open Solaris. It was modeled off of the MPL license, so it's very similar to the MPL license. And at Joint, all of our open source stuff uses the MPL v2, which is, again, very similar to CDDL. Now, let's see. Containers are lightweight and efficient. And as services become smaller, which we're now seeing with microservices, you can deploy a full API for some application in, like 64 megs, which is increasingly becoming common. But Joint had always emphasized the operational characteristics of zones and of containers and the operational advantages. Much later, other people started to look at containers as a platform as a service mechanism for deploying applications. For example, one company called .cloud, which, has anybody heard of that? .cloud, you did? Have you seen this before?
They presented at UUASC-LA.
Did they? Okay. But they had a real hard time actually marketing and monetizing their platform as a service product. So eventually, in 2013, they pivoted, open sourced their platform as a service component, and that's when Docker was born at 2 minutes into this presentation. So yeah, .cloud, now Docker, same company. Now the Docker model has created a paradigm shift with how you deploy things, putting things into their analogy is a shipping container. I think of Docker more as it's a heavyweight packaging system than it is a lightweight virtualization system. Docker itself doesn't provide any of the virtualization and container mechanisms on its own. It leverages the underlying substrate for that, right? But Docker, even today, has a number of challenges with it. It's really easy to make a Docker file, Docker build, and run something on your laptop. But then when you want to go and put that into production, now you have to worry about security. You have to worry about service discovery. You have to worry about networking. You have to worry about the NAT 6 ways to Sunday because you have no idea what port stuff is going to be deployed on. Security was never a part of that. As they say with Docker, like, don't run root inside of Docker, it's dangerous, which is something that's still not solved as of today. And so to address those kinds of challenges, what people have done is start to run Docker instances, Docker containers, inside of a hardware virtual machine. The main problem with that being that running a Docker application inside of a virtual machine negates all of its operational advantages. So SmartOS, which is Joint's fork of Illumos, which is a fork of OpenSolaris, we've been running multi-tenant internet-facing services in production for 10 years. So this is something that we had a lot of experience with. And seeing the advantages in the development model that Docker brought, we were really attracted to it, and we wanted to figure out if there was a way that we could get the best of both worlds, have the development agility and velocity provided by Docker, and yet also have the strong, secure multi-tenant deployment mechanism that we have been using for a long time. And so we resurrected a technology that was originally developed at Sun called LX branded zones, which allows native Linux binaries to run on top of the SunOS kernel. So completely unmodified, compile wherever you want to, and we'll just run them. And so we resurrected that. We completed it. The work was about a year's worth in 2014, and then we added a Docker API endpoint to that, the result of which we called Triton. Triton is half man, half fish. It's getting the best of both worlds.
So, but the kernel, the core kernel that you're running on, that's an Illumos-based kernel, is that correct?
It is an Illumos kernel, yes.
So,
yeah,
ported LX, did the LX run stuff, or the LX,
so
from a Solaris kernel to the Illumos kernel?
well, the Illumos kernel is a fork of Open Solaris.
Right.
Okay, so resurrecting that code, it's kind of funny because if somebody had said, hey, should we resurrect the LX code, everybody would have said, don't waste your time. There's no way this could possibly work. That it hasn't been touched in a long time. It just forget about it. Like, do something productive with your life because you're wasting your time. Fortunately, somebody that didn't know any of that pulled the code out of the ancient Open Solaris code base and just compiled and ran it on modern Illumos, and then sent a message to the mailing list. It's like, hey, if anybody's interested, like, here's a web rev of LX running on Illumos. Some people might be interested in it, and that changed the course of our year. Like, we dropped what we were doing, and we put a bunch of engineers getting on this. LX brand, as it stood when it was taken out of the Open Solaris code base, only worked with RHEL 3. It supported 2.4 kernel only, and like glibc 2.1, something like that. Some decrepit ancient, nobody would ever want to run this. And so over the course of a few months, we got 32-bit Ubuntu 12 running, and then Ubuntu 14, or actually Ubuntu 10, then 12, and then 14, and then we did 64-bit. Actually, getting the 64-bit stuff was a lot easier than the original, like getting stuff up, each rev up. But we had 64-bit Ubuntu booting in October 2014. And it worked with a surprising number of applications, and it worked really well. Linux applications mostly just don't know the difference. And we continued to add facilities, and now we can boot anything from Ubuntu 10 all the way through the newest Ubuntu 16. We support systemd. Yeah. Well, people like it's the default for Linux. So I'm sorry, but that's so we do support systemd, but we have full support for Illumos, Ubuntu, CentOS, and Alpine Linux. Which Alpine is like my favorite super small Linux distribution. It's rad. So yeah. Okay.
One other question.
Yeah, sure.
It seemed like I assume that like dtrace was helpful for doing first the KVM, the KVM port into Illumos and zones. And then also, I assume LX Run, dtrace was probably pretty heavy. I mean, you needed people to understand what's happening in the kernel in the first place, but then having a tool like dtrace probably was one of the reasons why, aside from it just the one guy being able to compile it on the first shot, was
well, what we did is we actually just had a dtrace probe running in the background that would print out every time there was a missing LX call. So we would just like run applications and like let it go until it bombed out on something. We're like, oh, okay, we'll add that one. Okay, now run it again and see how far we get. And so, yeah, like that work really could not have been done without dtrace.
Cool.
It would have been pretty much impossible otherwise. So, yeah. So Triton, in a nutshell, this is super brief. We use SmartOS as the base system. Okay, SmartOS is actually I have a slide on SmartOS later on. So, but it runs diskless, so in a RAM disk. Okay, it consumes about 262 megs of RAM as a RAM disk, and it's a read-only image. On top of that, we have instance images. So that's an image of Ubuntu or of CentOS or of SmartOS image, right? And then those are deployed into zones. Okay, so we've got OS zones, LX zones, and KVM zones. Okay, and so when we run a virtual machine, it's actually QEMU running inside of a container. So instead of like on AWS or OpenStack, you run a VM and then you run containers on top of that. We do it the opposite. We run KVM inside of a container because it's actually more secure that way. And then, so going to the orchestration stack, we have agents agents running on each compute node that report into the API stack. And then, let's see here. The data layer is Manatee, which is a state machine for Postgres replication and failover. Okay. And then Moray is a key value store that sits in front of Manatee. And so all of our APIs, like VM API, CN API, they all talk to Moray as a key value store. Moray talks to Manatee, which is where all of the data really is.
And I take it Manatee sort of this, it's a distributed, it's not a single Postgres instance, right? It's a way to make those calls, get them to off the system or whatever.
I'll get into
cool.
Manatee a bit more later. So and then we have our the API layer, and so we have all of our APIs as individual microservices. So the VM API for virtual machines, which when all of this stuff was written, nobody was talking about containers yet. So the term VM is pervasive throughout Triton. We really mean containers, but we're trying to get people to understand the concept at the time. So CN API is for compute nodes. NAPI is the networking API. Okay. And then we have the front ends, which are Cloud API, which that's end user customers talk to Cloud API. Cloud API talks to the backend APIs. And then we have SDC Docker, which is the Docker API endpoint, which again talks to all the backend APIs for orchestration. And then Admin UI, which is a web interface for managing Triton. And then we also have a component called Container Pilot, which isn't part of Triton proper, and it doesn't depend on Triton. So you can use Container Pilot not on Triton. You can use it like with your stuff in OpenStack or in AWS. Container Pilot is a service discovery and orchestration management component that goes inside of your containers. See, I'll get more into that in a little bit. So architecturally, Triton, it's a little blurry. So here's your conventional data center management and orchestration stack. You've got your physical hardware, some type of hypervisor, either Zen or KVM, and then on top of that, some cloud orchestration management system like OpenStack or AWS APIs, right? And then on top of that, you have virtual machines, and then actually missing from this is the OS that runs on top of the virtual machine. And then you have your container management platform, and then you have your container orchestration system, and then on top of all of that, you have your containers running way up there. And then you finally have your deployed application. Okay. So all of this middle layer creates a lot of abstraction, and it actually incurs a significant performance hit. Triton, on the other hand, we've got hardware, and then we have a converged orchestration and operating system layer. Okay, so this would be like SmartOS and the APIs that talk to it, and so then you run your containers directly on the operating system without having to have all of this mess in the middle of it. Yes.
So how would you say Triton is different from Rancher OS or CoreOS?
Triton is a data center management system. Okay, so something like CoreOS would be analogous to SmartOS. Okay, but there's nothing above CoreOS, right? So Triton is SmartOS plus the API stack. Okay. So CoreOS is interesting, I think, especially being a SmartOS guy. They took their pattern after the way SmartOS was built, having a very thin, what we would call the global zone. But Linux doesn't really have a name for the not container part, right? And then running all of your applications in containers. But again, like CoreOS doesn't have the multi-tenant isolation between containers that SmartOS does. Okay. So now drilling down into this a bit further, this is a kind of a high-level view of the architecture of Triton itself. Okay, so we have the head node here. The head node is the first system that you boot up in your data center, and the head node runs all of the APIs and orchestrates everything across your cloud. Okay, and then down here we have a single compute node. Okay, and so we've got the agents running over here, and this diagram's kind of old, so the labels here aren't actually the names of the things that we use now, but so we have now VM agent, CN agent, and net agent, and those are the agents that run on the compute nodes, and those broker interaction between the API requests and what's supposed to happen on compute node. So then we've got our containers here, and the virtual NICs that are assigned to each container, and then ZFS file system, right? Yeah?
What's SDC 7 core services? What's SDC?
Yes, okay, so before the name Triton, so we had SmartOS, right? The branding for this product was previously Smart Data Center, and so it was Smart Data Center version 7. You can kind of think as Triton as like SDC version 7.1, but we're really going for the Triton branding these days. So yeah, like I said, this is kind of an old diagram. What's that? Okay. So the agents talk to, they used to talk exclusively to an AMQP broker. Now they talk to the APIs directly. So we've got the DHCP zone. So when a CN boots up, the first thing it runs is iPXE, pulls down the operating system image from the head node, and then it boots SmartOS. Okay. Binder is it's a takeoff of bind, right? It's a DHCP service. Whenever an API starts up, it will register itself in Binder so that other services can locate it, right? And then we have the operator portal, which is admin UI, the customer portal, which is like our one remaining closed source component, and the public API, which is called Cloud API. And then there's the core services here, which look like this. Probably I'll just breeze through this real quick. Let's see here. Okay, so head node running, and let's see. Yeah, okay, so we've got our various APIs here. I'm gonna go more into these APIs in a little bit when I get to the live demo, so I'm just gonna kind of gloss over this a little bit. The APIs talk to the key value store, which is Vore, which runs on top of Manatee. And then that can link up to other data centers. Okay, so if you have, like Joint has multiple data centers distributed across the country, you can link those up to share data between them, right? And so, okay, very quick primer of SmartOS. Some of this I've mentioned already. It's a type 1 read-only hypervisor, okay? So it boots from either a USB drive or from Pixie. We have kind of like a demo instance that you can run in VirtualBox or VMware. And so you can get an ISO to run in those or a VMDK. But for running in production, it's recommended to use the USB image to boot off of, okay? Or if you're running a full data center, you boot the head node off USB, and then other systems will Pixie boot off of that. We use package source for package management in collaboration with the NetBSD project. Package source is really, really cool. I could do a whole talk on just package source, but very briefly, it has about 15,000 source packages in it, which is on par with about what Debian has. And it supports 17 different operating system platforms. So whatever you're running on, you can get package source and run it there. It's really nice because I can get the same version of Nginx on anything that I'm using. I have package source on my laptop, right? I've got package source in the data center. I've got package source on my Raspberry Pi, right? I can get the same version of everything, the same behavior. I don't have to worry about variances in, this distro or whatever. So it gives me a very nice, consistent experience across whatever platform I'm running on. And of course, ZFS, Zones, dtrace, oh my. The unsung hero of SmartOS, any Illumos or Sun-derived system is SMF. SMF is amazingly awesome. I'm going to go into it a little bit later. It's what systemd wishes it could be if it. I'm going to try not to say anything bad about
that's for post-meetup discussion
Yeah.
over beers.
Yeah.
And maybe some thistles.
So, yeah. Sometimes a container just won't do. Sometimes you actually need to be running the full kernel that has all control of the hardware, or at least it thinks it does. So we support KVM, so you can do that as well. You can run FreeBSD, you can run Windows, you can run Linux in a KVM virtual machine. And it's derived from Illumos, which is descended from OpenSolaris. And if you're interested, go search YouTube for Fork Yeah, where Brian Cantor talks about how Illumos came to be. It's a very entertaining presentation, and he's got some choice words about Oracle in there.
We also, we hosted Garrett Diamore, did one of the first
Yes.
Illumos presentations here at UUASC-LA. And he actually just spoke again on something, the Illumos, something.
I watched that one. That was just last month.
Yeah, yeah.
Mhm.
So, yeah,
Yeah.
some of us are hip to that stuff.
Yeah.
It's cool. Not Linux. It's cool.
So that's all the slides I've got.
Yay.
Go back over here. Let's see here. Setup time completed, 619 seconds. So less than 11 minutes.
Yeah.
So,
Shout out to
oops,
Garrett.
let me, there we go. All right, let me click in here and hit enter. And now I can log into this thing. There we go. And actually, I'm going to do this instead. Right here. There we go. All right. Now, let's do, first of all, SDC role list. So you'll see the term SDC used pervasively. That's because of the old branding. And they told us, don't worry about like trying to rebrand everything.
Hey, by the way, can you do the other, flip it around the other? I think we'll do like this stream will get the better
Dark.
contrast
Dark?
with a black background
Yeah.
and the white.
Yeah. Okay. Oops. Where is my inspector? There we go. All right, close that. Let's try this again. There. Does that look better?
Yeah.
Everybody on the internet, can you see?
Oh, people in the room can see too.
Yeah. Okay.
It was just
All
too
right.
bright.
Let me reduce my font size a little bit so I can stretch this out. Yeah. All right. Still a little bit too wide. So what we have here is a list of the services. Actually, I really do want to get this. I'll switch it back. Okay, there we go. All right. Now, how big can we get that? There we go. All right. So we have our list of services over here, where they're running, the UUID of the instance, the RAM state, the role that it's running as. Because you notice the actual instance name is like Binder 0, right? Which is fulfilling the role of Binder. So if you have multiple instances fulfilling a single role, they'll get incrementing ID numbers on them. Okay, so it's not uncommon to have like Moray 0, Moray 1, Moray 2, right? And then we have the IP address of that instance, right? So there's a list of my VMs, and let's do a health check. And there we go. So there's the health of all my instances, and it says everything's healthy, which is good. All right, let me switch back over here to my list of things I want to demo.
Brian,
Yes.
did I see a compute node as one of the services there?
No. So the compute nodes, let me move this back over here. What I can do actually is right here. Okay, I'll boot up a compute node. So I've got this compute node right here. Okay, so now it's Pixie booting. And let's see here.
Cloud on a laptop, so that's why they're all called.
Yeah. There you go. And so now it's pulled from TFTP, the boot image and the kernel and the boot archive. Okay, and it's extracting those now, and it's going to startup. I will come back to this compute node in just a moment. I'm going to give it a moment to boot. Okay. All right, let's see here. So I'm going to do a couple of post setup tasks here. I'll put the spectrum. I see them. Post setup, common external NICs. So I'm adding external NICs to a couple of services. So this is going to add an external NIC to Image API and to Admin UI, so that you can access Admin UI externally, and Image API so that it can download images from Joyent. So added to Admin UI, and now, and so my poor little laptop's going to melt down running all this stuff. It goes a little bit faster when you're on real hardware. There we go. All right, and now I'm going to create my Cloud API instance, because you don't necessarily have to have a Cloud API instance. You could do all of your orchestration just through Admin UI. Yes?
So on the service you're running is Redis?
Yes.
Pretty much acts as a key value store.
Yes. So what is Redis for?
Yeah. Or why not just use Redis instead of one?
The reason to not just use Redis is because we use Postgres as the data backend. CAP theorem, right? Everyone familiar with CAP theorem? You've got consistency, availability, and partition tolerance. Pick two, and you can't do AP, right? You can do CP, or you can do, you can't do CA, right? So you can do like AP or CA, right? Or CP. So Joyent always chooses CP, consistency and partition tolerance. Redis can't give us the partition tolerance and the consistency that we need in order to run something like this. And Postgres can, okay? Moray has an HTTP interface to it, right, which Redis doesn't have. But we do have, where is it? Here we go. No, this one right here. Amon. Okay. Amon is a monitoring system, right? And so Amon has predefined probes in it, and it monitors the health of Triton. And so Amon's ephemeral state information is held in Redis. Okay, so we can blow away Redis and re-provision, like create a new instance of it, like all the data's gone, oh no. Amon will rediscover all the information automatically. Okay, and so that's what Redis is for Amon. Right. And actually, the Amon Redis instance is what Amon uses. The just Redis instance Admin UI uses for like cookie and session data, stuff like that, right? But all of Triton's data is actually in Manatee. Okay. So, and then I'm going to, let's see here, the thing's almost done booting there. This is in post, dev sample data. So I'm gonna load in here some packages and some images, okay? While that's loading, it's downloading about a 400 or 500 meg image here. While that's happening, I'm going to bring over Admin UI. Go. And show you what Admin UI looks like, although a gargantuan version of it. There we go. Okay. All right. I was doing some testing with this earlier, and I didn't have enough RAM, so I was having a lot of problems. I bumped the RAM up a lot on my virtual machine, so hopefully this will all go smoothly. Okay. Now, all right. So, oh, God, that's horrible. All right. Let me stretch this out. There we go. This is more what it's supposed to look like. I'm gonna have to like drag back and forth a little bit. Maybe this will work. So, what's that? Let's try that. Oh yeah, there we go. That's better. All right. Oh yeah. Okay. All right. So logging into Admin UI, we've got our dashboard here. We have a total of 23 virtual machines. These are actually these are actually container instances. Okay. Like I said, the term virtual machine is pervasive, even though we don't really mean it. We have one user, 2 servers, 2 reserved, provisionable in total. So we have 8 gigs of total RAM in the data center right now, and utilization is 100%. So if we look at our virtual machines, which is, again, instances, here's a list of all the containers that are running in the system right now. And this will list, however many you have across your entire data center. So you can search by UUID, the alias, package. Let's hop over to packages. Packages are a set of dimensions for your instances. So how much RAM, how much CPU, how much disk space to allocate. Okay, that's called a package. And so we have the SDC core packages here, and then we have the sample packages that I just loaded in with the dev load sample data command, right? And then, so here's our images. Each API microservice has its own image. And then let's see if it's done yet. Base. There we go. Nope, not yet. So it's still loading in. Yeah, so base 64 LTS and minimal 64 LTS. Those are still downloading. So, but you can go here to import image, and let's do like Alpine Linux. And so here's the different versions of Alpine Linux that we have, and I can import one of these. These are actually small, so I'm gonna, let's see here, this one. Okay. So now this kicked off a workflow job, which I will close that. Come over here, workflow jobs, and here's the workflow jobs that are running. So we have these 2 remote image imports that are running, and then this is the last one that I just kicked off. So for any of these workflow jobs, you can hop in here and see the status and the raw output of everything that it's doing. So I'll go more into this a little bit later. So servers. So here's our list of servers. Here's the head node, and here's our other VM compute node that has booted up. So I can click Setup Server here, but I'm actually going to do it from the command line. Let's see here. This is still going, so let me pop up a new one. Okay, and SDC server list, and there's a list of all of the compute nodes in my data center. So I've got the head node right here, and my new compute node right here. It says setup false, so I'm gonna go ahead and set that up. SDC server setup, and give it this UUID, and did that do what I wanted? Set up minus S UUID, that's what I need to do.
minus S?
Minus S is just, here's a list of servers.
Okay.
Okay. So I'm gonna do that. Oh, I guess it did actually do it. Okay. So let's look back over here at our jobs and server setup running. So this is the step that it's on. And so it's running that task on the compute node. And when it progresses, you'll see things pop in here. Okay. And let's see where this other task is at. That's still downloading. Okay. I actually hadn't planned on adding a second compute node. I did that just for you. So let me get back to my list of demos where we sample data. Oh yeah.
Wait a second, you said the second node is the compute node, right?
Yeah, so they're all compute nodes. Like all the servers, we call them compute nodes. We have one special one called the head node, which is where all the orchestration happens, and everything else is a generic compute node.
Okay, can you spin up containers for your users on the head node?
Not generally, no. But there is a post setup task called right here, dev head node prov. So convert the head node to something that's provisionable,
okay.
And then you can provision regular tenant containers to it. But that's really only intended to be used like in call. You wouldn't do that in production.
Okay.
Okay. So
But it works fine for a development stack.
yeah. Okay. So here's my server setup task, and you can see like it's progressed through and it's succeeded, right? So now if I switch back over here, here, and I do SDC server setup, not setup, list, and there we go. I've got my two compute nodes, and so over here now it says setup true. And I'm actually going to let's see here.
Sorry. There are two compute nodes, right? One's compute node.
One is a compute node, one is the head node.
Right.
Okay. You can see the host name here. This one is just the MAC address, which you can specify when you set it up. I just didn't. Okay. And then the other one, the host name is head node. Okay. And I'm going to scp .shid rsa.pub to call head node in root directory. All right, so let's go back. STC user ADM create -I. So I'm gonna create an initial user for myself right now. So you can do this with the API with the command line utilities. Our user database is it's called UFDS. When I'm not being recorded, I'll tell you what that stands for. It presents as an LDAP interface. So you can do like LDAP create, LDAP search, just with your regular LDAP utilities. We also have this SEC user ADM, which kind of wraps that stuff for you to give a better interface. You can also do this in users. You can go here and create user, but I'm going to do it on command line. User create, Bennett. Password doesn't matter because all end user interaction with SDC or with Triton is done through Cloud API, which uses SSH keys. Bennett. Oh, too short. All right. There you go. All right. Okay. User created. All right. SDC user ADM add key -f ID rsa.pub. Oh, duh. what user am I adding it to? There we go. All right, now I can pop over here and go Triton minus P col. I'll do packages because that's ready. And as soon as the API catches up, my poor little laptop here.
So you basically loaded your cert into like kind of the head node or whatever, then you get into.
I loaded it into my user. Okay. Connection refused. What? Let's see here.
Put it in the SSH directory?
What's that?
Didn't you just put it in your home directory?
So then.
No. Okay. So I copied the file over, and then what I did is I said add the key to the user B Bennett. The file to add is this. Okay. So I can actually do STC user ADM B Bennett. Let's see here. Get keys. Let me just. So keys. That's what it is. And there's my key. Right. And let's see here. All right. So. Yeah. All right. Now this actually gives me a chance. I'm going to. So over here, I had connection refused. Right. So I'm going to try to figure out why that happens. And the first thing I'm going to do is vmappy VMs / STC VM name Cloud API. Okay. Everybody familiar with subshells, right? Do you know what I'm doing here? Yeah. So I'm running the command STC VM name Cloud API, which is going to return me a UUID. Okay. And then I'm using STC vmappy to call /VMs / whatever that UUID ends up being, so that I can get the JSON properties of the Cloud API instance. Okay. And then I'm going to filter this through JSON, and I want Nix. And here we go. External, let's see here, 82. There we go. That's why the IP address changed. So let me oops. Col.
Where did this file come from, Brad?
So okay. All right. So the Triton command line utility is it's written in Node. Okay, or it's written in JavaScript, runs in Node, and so that is our command line interface for interacting with Cloud API. Okay. To install Triton, you just do npm install -g Triton. And then what you would do after that is do Triton profile create, right? Which I have already done because I have many Triton profiles, okay? Which are in .triton profiles, and there's all the files, right? And then we can look at col, oops. And it's just a small JSON object, okay? So my account name, B Bennett, my SSH key ID, the URL for the API endpoint, and I have insecure true turned on, which turns off TLS validation, because I'm just doing this with the virtual machine on my laptop. So I'm fairly sure that somebody's not hacking me in the middle of that. So, and even if they are, this is all just phony data anyway, so I don't really care. Okay, so now I can do Triton, let's see here, profile set.
Right, that lets you do it with self-signed certs as well.
Yeah. So now I've set Cole as my default profile. I can do Triton profiles, and there we go. So we can see the Cole profile is selected currently, right? And then I can do Triton packages. There we go. And so these are the packages that are available for anybody to use. If we go back over here and we look at the packages, you can see that there's these SDC packages here, but these are owned by the admin user, okay? So things like networking objects, packages, images that are owned by specific users can only be seen by those users. And so objects that are not owned by anybody, anyone can see them, okay? So we have both public objects and we have private objects. Yeah, yep, yeah. And again, I mean, so Joyent runs a public cloud, right? This is the software that we use to run our public cloud. We don't, like, there's not a separate thing that we try to sell to people. We built Triton to run the cloud. And Joyent is the only company, the only cloud stack that does that. Rackspace has a set of like Ansible scripts that will install OpenStack for you, but they don't make OpenStack. They, you can use OpenStack kind of like the one that they use. I don't know how close it is to what they actually run internally or what else they add on to it. But even if it's exactly the one that they have, they still don't make OpenStack. We make it ourselves, and we do it for running our cloud.
So not only are you API compatible, but you're running the same code on the inside.
Yes, yeah. And so the reason that I have, I think I might, yeah. The reason that I have multiple Triton profiles is so I can point it at different data centers. So I can point at my Cole data center. I can point at the Joyent production data center. Okay, and it operates exactly the same. From an end user standpoint, there's no difference between on-prem or in the cloud. Okay.
From a kind of code perspective.
But from an end user standpoint, like an application developer deploying applications or an operator deploying instances. Okay, it's exactly this. You interact with it exactly the same, whether you're doing it on-prem or you're doing it in the cloud, which makes it really easy when you have a bunch of on-prem stuff and you run out of capacity. You can just burst right into the cloud just by changing the API endpoint. Okay, try that with AWS. Okay, let's see here. Back to some demos. Let's see here. Let's see, how aggressive do I want to get? So Joyent, we have bi-weekly updates, okay? So I have here USB drives that have Triton preloaded on them. Come pick one up, okay? You can plug this into a server and boot it up, and you will be running Triton. And you can do the install, as you saw, in as little as 11 minutes. Okay, I actually mentioned this to people at work, and they're like, "Oh, it used to be only like 5 minutes." So I guess it's more complex now. But come pick up a USB drive. Because we had a release 2 weeks ago, so the one on here is the July 21st image. Okay, we had a release today. I didn't have time to re-image 35 USB drives.
Does every Joyent employee have like a mobile USB thing so they can?
No, actually, I had 2 laptops going, and I had like I had USB drives. Like I have 2 on this laptop and 2 on the other, so I had like 4 going simultaneously to get them all done. So it ran over several days to get them done. And the release came out at like 4 o'clock this evening, something like that. Let's see here. So what I want to show you is how horrible the upgrade process is. So this is my wrapper script for like the full like update everything. And so SCC himself update, put the DC into maintenance mode, update the agents, add new agents, update other things, update GZ tools. GZ is the global zone. Okay, so there's lots of references to that. That's the thing that's where the actual kernel runs. Okay, everything else is zones or containers. Okay, the global zone can see everything. Individual zones can only see inside themselves. And then update all. This is where like the real meat is here. This update all command that updates all of the entire API stack. Which let's see here. I'm gonna try to do actually. Yeah, I can because I can pivot into the public cloud to do some of the demos. So I'm gonna do this update all. And
if you miss an update,
but
if it's not, updates missing, or just update all, does it all?
the update all will do all of it.
Okay.
Yeah. So you can say like update NAPI or update VM API and update just that one service, or you can say update all and it will do all of them. Okay. So I'm gonna go back here and back onto my head node, and oh, my image is finally finished. Okay. All right. So I'm gonna do this update all, and all right. So finding images, and it's like, okay, I'm gonna upgrade all of these images, right? And oh, I said minus Y up here, so it's doing it non-interactively. So it's downloading these images already, and we could.
Do these images depend on the base or the?
Yeah, they depend on the what we call the origin image, which is for most of them it's the SDC base image. So if we go here to admin UI images, so we have this. Actually, that's not the one. So SDC base 64, SDC multi-arch, and SDC Smart OS. Those are the base images that the API images are built on top of. Okay. And these are all ZFS data sets. And so, like SDC base 64 is the base image, and then like Manta off cache, for example, is just so like a snapshot was made of SDC base 64, and then stuff installed on top of that, and then a snapshot was made there. And so this image is just that next layer. Okay. So, and you can see that if I go, let's see here. I might be able to see it if I click on one. Oh yeah, image origin. Okay, and so here's the image that this image is based off of, the SDC Smart OS image. Okay, and see this one doesn't have an origin, so there's nothing there. So now I'll show you this real quick. So I'm going to grab the UUID here, and I'm going to go back over here, my other one, and I'm going to do SDC image API images and this image, and bam, there's my JSON manifest for this image. And you can see, let's see here, owner, here's the UUID of the owner, and then here we go, origin. And so there's the image origin, okay? And then if I wanted to know about this image origin, I can copy that and pull that one, and there you go. And here's the SDC Smart OS version 163 image. right? So same stuff. Actually, everything actually runs through the APIs, right? Admin UI, the only thing it does is talk to the backend APIs. It doesn't actually do anything itself. Like it doesn't talk directly to compute nodes. Same thing with Cloud API. It doesn't talk to compute nodes. It only talks to the backend APIs. And then the backend APIs orchestrate everything through the agents that are running on the CNs. Okay. There we go. Okay, back to this. All right, so this is updating over here. Still downloading images. So I'm going to now, let's see here. Got those things. Images. SmartOS basics. All right, let's do this. SDC server list. And okay, so here's my servers. Get this IP. Oh, no wonder. My compute node stole the IP that my former Cloud API instance was using. All right, so let's come here and SSH to this. There we go. All right. Okay, so now I'm on the compute node, right? And if I do vm-adm list, I have no instances running here, okay? As opposed to on the head node, vm-adm list, right? Okay, so you can run just SmartOS if you want to as a standalone compute node, or you can run a full data center with Triton as your orchestration system. There's also an orchestration system called Project FIFO, which are very good friends of Joyent. People think that there's animosity because they have an API stack and we have an API stack, and like they're competing, so we hate them or something. Not like that at all. Okay, they're total SmartOS friends. Anybody who's using Illumos, we love you right off the bat, right? So we could care less that you're doing something that's slightly overlapping with our business model. The more Illumos usage there is, the better it is for anybody using Illumos in the first place. So, you know, if you're gonna run Illumos but not SmartOS, like OmniOS, Open Indiana, I would love that. If you're using Project FIFO, I would love that. If you're using Triton, I love it more, but if you're using FIFO, I love that. So I'm gonna go over just a little bit of what it's like to run just SmartOS, aside from Triton on top of that. Yes?
One question about Triton. How about storage? I mean, it looks like everything you're doing is running on the local CFS file system.
Yes.
Or whatever you're setting.
Yes.
Each machine has its own CFS file system.
Yes. So network storage, now, there is some disagreement on this point, but at Joyent, based on experience, network storage in a multi-tenant cloud environment is a tire fire. It's a disaster waiting to happen. Nothing ever good comes from it. I'm sure you all heard about SourceForge going down for like 3 weeks because they had like a storage driver error that took out their entire SAN, and like everything was down for a long time. And the longer it went on, people were starting to wonder, like, is SourceForge going to come back up at all, or do they just go home? You know, a lot of the engineers at Joyent came from Sun, in particular the Fishworks group, which created the Sun 7000 storage appliance. And so there's, we have people that have been doing storage for a long time and building storage appliances. And there's a lot of deep experience at Joyent with how storage systems fail. And SmartOS and Triton have been designed to isolate fault domains, so that if you have a particular type of fault, you're not going to have a cascading failure that destroys everything. Okay?
What about integrating with something? Well, first, what's the take with the old guard on object storage? And also, what about integrating with something like Ceph, which is which as a storage system is this distributed thing. It's designed to, minimize the failure zones and all that kind of stuff.
So joint
can provide block and object. And they say the file systems in production, but you would
they say right. But the storage system that went down and nearly took SourceForge with it was Ceph.
Oops.
My only experience with using SmartOS was taking a box full of disks and booting SmartOS and using it as an iSCSI server.
Which you can do because it has the iSCSI stuff.
ZFS. So basically, I had a fabulous ZFS storage appliance.
Yeah.
Booted off a thumb drive.
Yeah,
and that ran for 2 years.
Yeah, SmartOS is like, it's descendant from the SunOS kernel, So like here, SunOS, right? It's descended straight out of Solaris, right? The only reason we don't call it Solaris anymore is because Oracle has better paid lawyers, right?
You'll be hearing from them in the morning.
The Illumos community knew better than to try to call it anything related to Solaris or stars or anything like that. So the closest we got is Illumos, like as illumination, like let there be light, right? That's the homage to Sun. Even Joyant, like the Joy and Joint is not a reference to Bill Joy. So it was actually the guy who coined the name David somebody, I forget his last name. He wrote an article about coming up with the name Joyant, and it was just like wanting people to be happy and joyful and combining that with enterprise. So, so that's where the name came from.
We're getting back to the storage. So you've got a bunch of server hardware. You've spun up a bunch of instances, and they're running in either whatever LX containers or zones, or KVM containers or zones.
Yeah, every zone has its own ZFS data set that it runs on top of.
Right. It's got it's kind of local. It's a like a snapshot of the file. So
and
its own.
And it's all local storage. Okay.
Right.
There's
on that piece of hardware that it's running.
Yes.
So, but when more data is needed, like they want to pull in data, or how do people do that? Can they iSCSI mount something, or can they just do? You're just curling in objects off of somebody's web server.
Generally, yeah.
And then put it back.
So
put and gets.
Talking about just Triton, there's a number of ways that you can handle that. There's an SMB client. There's an NFS client. You can curl objects in.
Well, I'm sure the Joyant folks that worked in Fishworks had a lot of great things to say about SMB stuff. But but this is as a client, I guess, as a coming outbound, it's not that big of a deal.
Yeah, I mean, so Joyant and Triton, we have no opinion on how you want to run your application. Like, if you want to use SMB as part of your application to access like data, hey, you know what? Go for it. If it's available in the OS, go ahead and use it. If we didn't want it to be used, we would take it out, right? So if it's there, go ahead and use it. If you want to use NFS for stuff, that's totally fine. If you want to use SMB for stuff, that's totally fine. if you're running Triton on-prem, you can have a delegated data set in your zone, which gives you a ZFS data set that you can actually do your own snapshots. You can create your own child data sets. Those delegated data sets are independent of the main image, so you can re-provision your image to a newer version or even a different application entirely, and the delegated data set stays there, so all of your data that's in that data set would be persistent at that point. Okay. So we also have an object store service called Manta,
Okay.
which I'm going to demo a little bit of Manta later on. I could do a whole talk just about Manta, so I'm going to briefly touch on it. But I was talking to somebody earlier. Before I started working at Joyent, SmartOS was my favorite thing ever. After I got there and I learned about what Manta is and how it works and how awesome it is, Manta is my favorite thing ever. So,
Are you married?
I am married. Yeah.
Wow.
Yeah. So.
Well, remember that Joy Manufacturing Company is a coal miner.
Okay. All right. Anyway, coming back off that tangent, going back
It
to
is getting late.
just SmartOS. Oh yeah, wow. Okay, so just SmartOS. Let's see here. All right, so image ADM list, right? I have no images, right? So I could do image ADM avail to show the list of images that are available to download. Okay. Now, because this compute node is attached to my Triton data center, it only sees the images that have been imported to my Triton data center, right? If you're using just SmartOS by itself, it will look at Joyent's image server to get the list of all the images that Joyent has available. Similar to when you come in here and you go to import an image. Okay, so SmartOS standalone looks at the same place that this would look at, right? And then, okay, so then let's see here. Let me see where this is at. Okay, that's still downloading stuff. So create base 64. Actually, LTS G4 2 gig rate minus is going to be UASC demo. There we go. All right. So what I'm doing is I'm using the Triton command line to create an instance. I'm using the base 64 LTS package or base 64 LTS image with the G4 high CPU 2 gig package. So that's 2 gigabytes of memory on that one. Minus N is the alias name that I want to call this. So this is called UUASC demo. And minus W says wait for this image or wait for this instance to transition to running state. Without the minus W flag, it will do it asynchronously. So this would return immediately, and then you can go about your business. There's also a Triton instance wait. So you can, like, if you spawn something asynchronously, you can then tell it wait for that instance to switch to provisioning. So actually, let's see here. I did that in the wrong place. I actually wanted to do, because I wanted, yeah. All right. And that's, let's go to packages.
Hey, Brian,
Yeah.
when we're starting to run late. We're getting, we're
All right, okay,
getting close
let's see
to
here.
9. We should maybe
Let's see.
start winding down, but there may be some good questions out there.
All right, I'm going to then skip over a bunch of stuff. Something I do want to show over here is, okay, so so here's all of my services that are running here. I'm going to log in to the CNAPI instance. Okay, so now I'm running inside the Canopy container. Service list. Okay, so this is a list of the SMF services that are running here. And I want to do tail -f Canopy Bunyan. Actually, I'll do it without Bunyan first. So here's like the log data that's streaming off of the Canopy service. And you notice that it's JSON formatted, right? It's not just JSON. It is a special form of JSON called Bunyan. Like that. Okay, and so this will reformat the data so that it's easier to read as a human. We use Bunyan extensively, and if there's something going wrong with your cloud, you can jump into any of the logs here and see exactly what's going on. You can see like stack traces or whatever. In particular, we have a request ID that's attached to every API request. So when it comes into Cloud API, it's given a request ID there. That request ID is consistent across every service, so you can grep all of your logs for that request ID, and you can gather logs across all of your services and then view them and find out exactly the path that everything took. We also have extensive timers for like everything that happened. So you can see like, okay, handler 7, that was the longest backend call to this one API call.
So you're kind of tracing, or you're getting a little performance histogram
Yes.
of every API call.
Yes.
So not only this API call took this long, but
here's how long
here's
all
the
the
long
dependent calls
sections.
took.
Yeah.
Yeah.
Interesting.
Yeah.
Because it's lightweight together, all that stuff.
Yes. Yeah.
Interesting.
So zlogin command can be used to log into any zones, right? Let's see here. What else? I want to do, okay, this one actually, all right. So I talked about LX branded zones, right? I want to show those off. I'm going to do Triton -PSW1, W1 create. Let's see here. Get the oops, SS1. There. Okay. Bunch of certified Lansing LX data set. So let's do this one. All right. So Triton create Ubuntu G4 CPU. Okay. All right. So let's get. What? All right. I'll use the ID. Oh, that's what I did. All right. I was on the wrong profile. Okay, so this hopefully won't take too long. While this is going, I'm also going to do Docker. So we have a Docker API endpoint. Okay. Grab Docker. So here's my Docker setup pointing at the joint data center. Okay. And now I'm going to Docker run over here. So I'm going to run an Alpine Docker image and just jump into a shell on it. Let's see what we got over here. So these are two forms of LX branded zones that I'm launching here. One is
so when you do sort of a Docker run, it's going to spin up an LX branded zone and
Yes.
stick and then slam the Docker.
Yes.
It's interesting.
Yeah. So I have my instance created here. So Ubuntu demo, right? Triton. Triton profile set SW1. Okay, Ubuntu demo, and so here's the JSON information. You can see my SSH public key right there. Okay, anybody got a good memory? Memorize that. Okay. So I also have DNS names that are automatically assigned. Every instance gets DNS names assigned to it. This Triton.zone is the external public IP address. The .joint.com is the internal private address. Okay, so I can SSH. So I have, this is the instance UUID or the short name. Okay, those will both work. So I can SSH directly to this. To that, and yes.
LS_release-a. Show us what you
No, I'm not logged in. Let's see here. Why didn't it like my key?
Because we should probably punt at this point.
This is probably not going to work because it's Ubuntu. Oh yeah. Okay. All right. I'm in. All right. So So I'm in here. LSB minus A. Oops. LSB minus A. Oh. Underscore. If LSB is installed. There we go.
Yeah, it's legit.
Yeah. Okay.
Too legit
So,
to quit. Now we're gonna keep this going until 9:30.
Dpackage minus L. Here's the list of all the packages that I have installed. Right. Let me know when you can tell this is not actually Linux. Okay. Uname minus A. There we go. Okay.
df-a, df space -h, do we have a file system?
There you go. There's our file system. Root is mounted on dev ZFS DS0. Okay. Forget I said ZFS right there, right?
Right.
This is it's totally Linux. It's not.
Well,
It's not just
1604 has kernel mode ZFS.
Yeah. It's totally not just an image of Ubuntu running on a Lumos kernel. Then uname minus A. Oops. User bin name minus A. But yeah, actually, SunOS, here's my UUID, version 511 joint, and there's my version number, right? So it is actually in a Lumos kernel down there. Notice this native directory right here, native user. That's the SmartOS user directory that has been mounted inside of the LX image, okay? So you have, for example, native user sbin dtrace.
Oh, so the native user that's how you run the
Yeah. Yeah,
Smart
so-
OS kernel stuff.
The platform image, all of the Smart OS utilities from the base operating system are mounted here inside of the LX zone.
Would that be called federal zone? So you have native data that will show you Darwin?
No. This is running in the joint data center. This instance, I pivoted quickly, so
Because we were
you guys
running
didn't notice that. Yeah, you had a question?
Uh,
This native is mounted from the global zone. Yes. Which sometimes can get confusing because SmartOS has a thing called strace, which is not what you think it is. Okay. So we actually don't recommend putting native in front of your path in an LX zone. If you want to add it to your path, put it at the end.
Or just call it out explicitly.
Or just call it out
Everybody knows.
explicitly. Yeah. Also, not everything out of native is LX aware. So like IPADM, which does interface management, isn't LX aware. So it gets kind of confused when you call IPADM. But I can do IP adder show, just like Linux. Okay, IP route show. There's my routing table. Okay.
Oh,
Can you tell it's not Linux?
just like home.
Yeah. And so because we have a cloud with thousands of tenants on it running these LX brand zones, let me show you something over here. Oops. Head node, ZFS list, grab cores. All right. Every zone that gets created has 100 gigabyte ZFS data set assigned to it that just collects cores. Okay, so an application that crashes anywhere across joins infrastructure, those cores get collected here. They get uploaded to a system that we have called THOF that we use to analyze the cores. So we've actually identified and fixed bugs in software that we don't run because we saw it happening so pervasively across our data center. Like we're like, here, we fix this for you because we know it's a major problem. It happens all the time. Yeah, like PHP, cores everywhere. But yeah.
So we should probably start wrapping it up.
Yeah. Okay. So let me. Let's see. My Docker timed out here, but it has the same thing. So inside of Docker, you've got the native directory there. Okay. So one of the demos I had was like running running the shell in one terminal, popping to another one, doing a Docker exec for dtrace, and then like detracing all of the processes that are run, and then like install a package over here, and you can see everything happen.
Cool.
So you can spin up a container from Docker, okay, which is secure, isolated, first-class networking stack, persistent data storage backing it. It's not something that's just ephemeral like it is with Docker elsewhere. And then you can like Docker exec dtrace on that and run dtrace on your running live application that's serving customers. Because that's the kind of thing that you actually really need to do when you're running services
You can do
in
that.
production.
So you can have a running Docker container and then externally dtrace that container.
Yes.
Cool.
And have the display pipe directly back to
And
you.
get that dtrace output out to debug it.
Yes.
Awesome.
Yeah.
That is awesome. Do the Docker folks use that? I mean, have they gotten into that for?
Well, so Docker exec is, I mean, that's something that's part of Docker itself.
Mhm.
Okay. The dtrace thing is something that you get because it's running on top of SmartOS instead of
Right.
running.
No, but I'm saying, have they got into that? Have they tried using that for debugging? right? Because they could theoretically.
Well,
What are your USB keys?
I'm
Load it
sure
up.
that, oh, you mean, does Docker use Triton for debugging?
Right, or yes.
Not as far as I know.
Because you're emulating their API, it's none of their code on the server at all.
Correct. Yeah, it's we re-implemented the Docker API in Node.js. Okay, so because
You can use the Docker client on your box to talk to
Yeah.
the guy, but we're not running the Docker server.
yeah, as it turns out, the Docker daemon has a very significant reliance on back-end Linux mechanisms. So there's work going on inside of Docker to bring Docker to Solaris, which is still not out yet. And we've had S2C Docker for 2 years. So yeah, I had a short conversation with Solomon Hikes a couple of weeks ago, where I was like, hey, he was saying like, oh, Docker and Solaris. I was like, or you could just do it today on Triton. And he didn't really like that I was pointing that out to whoever it was he was talking to. Let's see here. Let's see here. Okay, so I talked about the DNS names. I'm really proud of that because I worked a lot getting that infrastructure up and running for all the DNS names to work. That was one of the things that I was particularly interested in making that happen. So,
right. And the cool thing with the Triton SmartOS bit is you're working on that. You may be solving an internal joint hosting problem, but since that code gets within so many weeks, that code's going to get pushed out, and everybody with their own on-prem instances benefits from that stuff.
Yeah. Speaking of which, let's see where our upgrade is at. Okay, here we go. It's actually my goal is upgrading services. I'm not even watching it. It's just doing it, right? You can watch Twitter or search Twitter for like Triton upgrade, and all you see is people talking about how boring it was because it's like nothing ever breaks during Triton upgrades. Okay, which isn't entirely true. Things do break, and like being at Joint and upgrading stuff there all the time, like I encounter the breakage a lot, but we try to fix things before stuff gets out to on-prem customers. So most people think it's never a problem. I have problems. I'm glad other people are insulated from that.
So
You fix them, right?
I try to.
right before they get out.
Yeah.
Okay, so yeah, because we really do need to kind of wrap it up. But so how is like I guess Triton or like how much usage is out there? Like how many people
are using it on-prem?
Is usage, and then how much, and then
So
how many on-prem some of them you may not be aware of, but
yeah, Joyent has 4 regions, 8 data centers. We've got Southwest, which is Las Vegas, West, which is San Francisco, East, which is Virginia. We've got East 1, 2, and 3, and we have East 3B, which is a beta environment. There's daily updates to that. So if you want to be like on the bleeding edge of what Joyent has to offer, we've got the East 3B data center for that. And then we've got data center in Amsterdam for Europe. Okay. I can't really talk about our customers in depth. I can say that we have Samsung as a customer because Samsung recently bought Joyent, so they're now our anchor tenant. So we're building out some really large data centers for them. That's what's got me the most busy right now. We have an on-prem and cloud customer that I'm not going to tell you who they are, but it's a Fortune 1 company. We have major media. We have a major media company in television. We have a major networking company. We have a major like food and services company, like companies that you would know of if I told you what they are.
Cool. And so some are just cloud, some are cloud and on-prem, or
Yes.
or do you think maybe as Triton gets formalized, do you think you're going to see more on-prem?
I'm hoping so. I mean, like I said, the advantage of Triton, one of the advantages of Triton is that you can use it on-prem and have the exact same experience as in the cloud. So you can burst directly into the cloud, which is something you can't do anywhere else. You know, if you're using AWS and you want to do some on-prem prototyping, you have to have a completely different development model. If you're, you know, if you're using like Rackspace OpenStack, but you've got your own OpenStack, it's probably not the same. You know, there is no vanilla OpenStack, and there never will be.
Right.
Like that's not my claim. That's what OpenStack says.
Right. It's a 6-month open development cycle.
Right. And not only that, they won't even give you a list of like, here's the things that make up the core of OpenStack. There's a OpenStack is like an umbrella project where there's, you know, competing things performing each role. And we're not going to tell you which one we prefer for each role.
And
right?
developing, it's also just, there's a lot of development.
Yeah. Well, I mean, you know, Triton has a 2-week release cycle, right? So I can't fault anybody in particular for having a certain style of release.
But the other interesting thing with Triton, though, is you've got ZFS at the base. So that means you've got solid data integrity and snapshots.
Yes.
And boot environments and rollbacks and all that kind of stuff.
Well, SmartOS doesn't use boot environments because we pixie boot the entire platform image.
Okay.
So if we want to upgrade something, we just reboot to the new platform image. You know, if it didn't work and we want to downgrade, we just reboot to the old platform image.
Okay.
So it's there's no OS to install. It runs entirely from the RAM disk. So you can't corrupt it. You can't screw it up. You never get to a situation where like, oh, there's so much crap running on this, it's so slow now. That doesn't happen.
So that's another, you guys have been doing kind of immutable infrastructure for a while too.
Yeah.
I mean, that was SmartOS was immutable infrastructure, at least at your kind of hypervisor level from the get-go.
Yeah.
Not only is it ZFS under the hood, Jordan, but it's also the Solaris kernel.
Right.
The Loomis kernel.
Right, which, so you get the strong isolation with zones, okay, which, again, was designed as a security mechanism. The original paper for jails was subtitled Limiting Omnipotent Root, okay, making it so that root can't actually run the entire system. You give it a small subsection of the system that it has control over, okay? And so, you know, zones gives you a full, what looks like an entire independent OS. You know, when you're running in a zone, you can't really tell that you're not in control of everything. It really seems like you are.
But since it's all segments of the same kernel, it all runs a lot faster. The instances boot a lot
you don't have the layer of virtualization in the middle that's just adding, you know, 300 milliseconds of latency to your disk calls. Okay, or to your networking calls.
Cool.
Okay, we have some. If you go to the Joyent blog, we have some demos and some benchmarks which are on GitHub, run like as Docker images. So you pull these Docker images down, and you can run it on Triton and on AWS, and like do the performance test yourself. The numbers that we got on that particular day, some of the numbers are like 400 times faster running on Triton because you don't have that layer of fat in between you and the actual hardware.
Cool. Well, I think we should probably leave it at that. Unless you, for one thing, can you post, maybe give us a link to your slides at some point? Are those?
Yes, I'll send you an email. Good. With it because I haven't uploaded them anywhere yet.
Cool. Well, when you're ready.
Yeah.
Because I can pair it up, we put it in with the live stream leftover video. That'd be nice. And is there any other places to look for other stuff? You know, what's some if people are interested, where should they? Where can they get hip to Triton SmartOS?
So on our website, okay. So we've got extensive documentation on our website. Oh, also wanted to show this over here. I've got the tab. Oops, wait, where is it? Here it is. Not that one. Jeez, where is it? There we go. This one right here. This is our documentation on the APIs. Okay. So, for example, Knappy, right? These are all of the API calls and how to call them. Come on. Yeah, this is all on GitHub. So you can go to github.com/joyent/Triton. Okay, that's your starting point if you want to download it. So allocation API. It's called select server. You do a post to allocate, right? Boot parameters, get boot default, right? Get boot server UID. Let's see here. Compute node agent task API. Okay, so get tasks and a task ID, right? So we have extensive documentation for the APIs. I like this. This is like my browser homepage, right? I'm on this all the time. Everything that you could possibly do with the APIs is documented in here.
Cool.
So.
All right. Well, let's we should probably leave it at that. Hey, thank you. Thank you very much, Brent. And hopefully you can come back and talk to us about Manta, right? Might be very interesting, broken out thing. And Pat, you said you're a big package source fan. And I'm going to stop the recording in a second so that you can tell us the what the your name service acronym. What was the acronym?
Oh, CNS, Container Naming Service.
No, but there was the like kind of the LDAP thing. Yeah.
Oh, UFDS.
Yeah. So you can tell us what UFSDS. But hey, thank you very much.
Yes, you're
I'm
on.
gonna stop
Oh,
the
one more
recording.
thing before you stop
Okay,
it. We have Container Summit coming up in LA on September 22nd. Come out and see us there as well. Yes, come get USB drives. I have T-shirts over here.
Swag.
Some sample shirts over there so you can see what kind of style you want.
Go to the UUASC-LA meetup to register for the Build the Cloud Day. We'll have
Yes,
that posted.
Build the Cloud Day.
Yeah, I got one.
All right. Thank you, bro.